viewers. Welcome to Simplified Maths. And in our class today, we'll be going straight to Quadratic Equation Part 2, which is completing the square method. The last edition we had in Quadratic Equation, we dealt with factorization method. We made mention that a quadratic equation is an equation which is expressed in the form ax squared plus bx plus c equals to 0, and that the roots of the quadratic equation can be derived using four methods: factorization method, completing the square method, the formula method, and the graphical solution. So today we are taking the completing the square method, and we'll be taking the two examples we used in factorization to see if actually all the methods can still give the same result. The very first one was x squared plus 2x minus 15. X squared plus 2x minus 15 equals to 0, and we had two results, I think 3 or minus 5. Those are the two results we have. So let's see if the roots are still the same by completing the square. So when we are using completing the square method, it is an iteration process, a step-by-step process. We'll follow all the steps to the end. The first step is to collect like terms. Collect like terms. By collecting like terms, you're going to have x squared plus 2x equals to minus 15 crosses the equality sign. We have plus 15. So the second step is to divide through by the coefficient of x squared. Divide all through by the coefficient of x squared. And now coefficient of x squared is the value in front of x squared. If it is 3 or 2, you write that as the coefficient. But since there's nothing in front of x squared, it means that the coefficient is 1. So we are dividing through by 1. Alright, so we divide through by 1. So we have x squared plus 2 over 1x is equals to 15 all over 1. So after dividing through by x squared, the next thing is to multiply the coefficient of x. Multiply the coefficient of x by half, and you square it. You square the result. So we are going to multiply the coefficient of x by half and square it. So multiplying the coefficient of x, we are going to have, initially we had x squared plus 2 over 1x. Now we'll take the coefficient of x, which is 2 over 1, multiply by half, and then we square it. Alright, so we have 15 all over 1. Now, if you look at it, you see that this now is a new term that is introduced to the previous term. So the only way to balance the equation is to add this result to both sides. So we are going to have x squared plus 2 over 1x plus the new term added, 2 times 1, that's 2 over 2. All squared will be equals to 15 over 1. We add it to both sides, 2 over 2 all squared. That's the only way you make it a perfect square. It means we have to add that result that is introduced to the previous term to both sides. So we are going to have, at this point, you pick 1x, and then you pick what is in the bracket, 2 all over 2 all squared is equals to. It means that if we expand this, we are going to have this. For lack of time, I won't do that, but at your leisure, just expand this, meaning x plus 2 over 2 times another x plus 2 over 2. When you expand it, you still have back what we have here originally. So this will be equals to 15 over 1 plus 2 squared is 4 over 2 squared is 4. So we find the LCM of this. So the LCM is 4. 1 into 4, 4. 4 times 15 is 60. Plus 4 into 4, 1. 1 times 4 is 4. So it means that we are going to have x plus 2 all over 2 all squared will be equals to 60 plus 4 is 64 all over 4. So what is left now is just to find that simple, and by expanding it out to do a simple work left, and then you are done with the whole thing. So at this point, we are going to have x plus 2 all over 2 will be equals to, this square now crosses the equality sign to become plus or minus the square root, 64 all over 6. So when 64 all over 4, when the square crosses the equality sign, it becomes plus or minus the square root of what you had originally, which is 64 all over 4. So at this point, you are going to have x plus 2 all over 2 is equals to plus or minus. The square root of 64 is 8, and the square root of 4 is 2. So at this point, x will be 2 over 2 positive crosses. So that would be negative 2 over 2 plus or minus what you had originally 8 over 2 in the other side. Now since the denominators are the same, you pick them as 1. X will be equals to minus 2 plus or minus 8 all over 2. 2, you take it as 1. So at this point, you're going to have your x to be equals to minus 2 plus 8 all over 2, or minus 2 minus 8 all over 2. Alright, so we are going to have our x now to be equals to minus 2 plus 8, that's 8 minus 2, 6 over 2, or minus 2 minus 8, minus 10 all over 2. That gives our x to be equals to 6 over 2 is 3, or minus 10 over 2, which is minus 5. So we still have the same roots we had when we solved by factorization. Now there was a second example we took where the coefficient of x squared now is greater than 1. We are still going to try that by completing the square to see if we still have the same results. Alright, so I think that second example we solved there was 6x squared minus 7x plus 2. 6x squared minus 7x plus 2 is equals to 0. We had, I think, half as a result, or 2 over 3. Those were the results we had. Half or 2 all over 3. Okay, so we are going to solve that by completing the square to see if we still have the same answer. As usual, first step is to collect like terms. We collect our like terms. So if you collect like terms, you're going to have 6x squared minus 7x is equals to plus 2 crosses to be a negative 2. The second step, we divide through by the coefficient of x squared. Divide through by the coefficient of x squared. Divide through by the coefficient of x squared. Well, we divide through by the coefficient of x squared. The coefficient of x squared is 6. So that will be 6 divided by 6 minus 7x we divide by 6 minus 2 we divide by 6. We are dividing through by the coefficient of x squared. At this point, 6 crosses 6, you have x squared minus 7 all over 6x will be equals to minus 2 all over 6. Now, the next step is to multiply the coefficient of x. Multiply the coefficient of x by half. And do what? And square it. Okay, so we are going to have originally x squared minus 7 all over 6x plus. That's what we are introducing now. We are taking the coefficient of x, which is minus 7 over 6. We multiply it by half and then we square it. You can see a new term has been added. So which is equals to minus 2 all over 6. So we are going to have x squared minus 7 all over 6x, which was what we had originally. A new term is introduced. Minus 7 times 1 is minus 7. All over 6 times 2 is 12. All squared. So that result has to be added to both sides to complete the squares or to make the equation balance. So we are going to have minus 2 all over 6. We are also adding a negative 7 all over 12. And then we square it. Take note of that. So at this point, we take just an x, the x here, and you take whatever is in the bracket, minus 7 all over 12, and then all squared. Meaning that if we expand this, we'll have back this. If we take x minus 7 over 12 times x minus 7 over 12, we are going to still have originally what we have here. We have completed the square. It means this is the term that has been added to the equation to make it a perfect square. That's what it means. So this will be equals to minus 2 all over 6 plus minus 7 squared will be positive 49. All over 12 squared is 144. Alright, so at this point we are going to have x minus 7 all over 12 all squared will be equals to, we take our LCM. Our LCM will be 144. Alright, so 6 goes to 144. That will be 144 divided by 6. So you're going to have 24. 24 times a negative 2 give us a negative 48. Plus 44 into 144, 1. 1 times 49 is 49. So we just have to simplify that and we are done. So let's go into the simplification of that and see what we are going to have. So at this point, we are going to have x minus 7 all over 12, all right, all squared will be equals to 49 minus 48 will give us 1 all over 144. So the square crosses, so we have x minus 7 all over 12 will be equals to plus or minus the square root of 1 all over 144. The square crosses to become the square root, but you have plus or minus, meaning that two values are involved. So therefore, it means our x will be equals to a negative 7 over 12 will cross to become a positive 7 all over 12, plus or minus. What we have here is the square root of 1 all over 144. The square root of 1 will give us 1. The square root of 144 will give us 12. So at this point, we are going to have 7 plus or minus 1. 7 plus or minus 1. We have the same denominator. We take it as 1. So our x now will be equals to 7 plus 1 all over 12, or 7 minus 1 all over 12. Please take note of that. So we have 7 plus 1 over 12, and then 7 minus 1 all over 12. Our x will be equals to 7 plus 1 is 8 all over 12, or 7 minus 1 is 6 all over 12. Our x will be equals to, we simplify the fraction, 4 here 2 times, 4 here 3. Here we simplify 6 here 1, 6 here 2. So therefore means that our roots of the equation are 2 over 3 and half. 2 over 3 and half. The same result we had when we solved by factorization. So you see, whichever method you decide to use, you must always have the same term. But the examiner tells you the method you have to use. And I know that so many students run away from completing the square. Just follow the iteration process step by step, and you will solve by completing the square without any hassle. Thank you for subscribing to our previous video. We also beg you to please subscribe to this video and like it if you enjoyed it. God bless you, and see you in the next part, quadratic equation part 3, which is by the method of formula, almighty formula. Cheers.